The next question is, 3 of the 6 vertices of a regular hexagon are chosen at random. The probability that the triangle with these 3 vertices is equilateral equals, express your answer in decimal. So let this be the hexagon. And we can have these triangles. Now there are 6 vertices in a hexagon. Using 3 out of 6 vertices, we can form 6 C3 triangles. But there can be only triangles out of 6 C3 triangles which are equilateral. So there can be only 2 triangles which are equilateral out of the 6 C3 triangles. So the required probability is equal to 2 by 6C3 is equal to 2 by 20, that is 1 by 10. So 0.1 is the required probability. The next question is, the radius of a cone is root 2 times the height of the cone. A cube of maximum possible volume is cut from the same cone. The ratio of the volume of the cone to the volume of the cube is dash up to 2 decimal places. Now, let each side of cube be A. Then, okay, so first let me draw the cone and the tag cube first. So this is the cone, and we have this cube. This is A, B, C, D, O, and this is Q and P. So then CD is equal to root 2A. Therefore, CQ is equal to root 2A by 2, that is A by root 2. Now let the radius of the cone be R and height be H. Then R is equal to H root 2. Now in triangle APO and triangle CQ and similar triangles we have AP by PO is equal to CQ by OQ is equal to R by H is equal to A by root 2 by H minus A. Now this is because triangle APO is similar to triangle CQO. Or A by root 2 by H minus A is equal to root 2, or A is equal to 2 into H minus A. Therefore H is equal to 3a by 2, or r is equal to 3a by 2 into root 2 . Therefore, volume of cone is equal to 1/3 pi r squared h, that is 1/3 pi into 3a root 2 by 2 squared into 3a by 2, that is 9 by 4 a cube pi, and volume of cube is equal to a cube. Therefore, required ratio is equal to 9 pi by 4 a cube by a cube, that is equal to 9 pi by 4, that is equal to 2.25 pi or 7.07. So the required ratio is 7.07.